Welcome to the overview screencast for our continuous deployment pipeline project. The project is divided into 4 milestones by topic, and this overview video will follow that structure as well. The first milestone topic is configuration management and build. For this milestone, we first wrote a Vagrant file to automatically provision and configure a local Ansible server. We then used the AWS SDK for JavaScript to automatically create an EC2 instance and then configured it for Jenkins using Ansible playbooks. As part of the Jenkins configuration, we created 2 build jobs, one for checkbox.io, a Node.js project, and one for iTrust, a Java project. We then set a post-build task for each build job that would appropriately configure and provision an EC2 instance or DigitalOcean droplet for that application. The second milestone topic is testing and analysis. The first task of this milestone was to create an automated fuzzing tool. The tool first randomly selects a set of predefined fuzzing operations and performs these on this Java source code. It then ensures that the code can compile, and if it can't, then it undoes the changes. If it can compile, the code is committed, which triggers a Jenkins build. During the build, test results and code coverage are recorded. When the build completes, the commit is reverted, and we repeat this process 100 times. The second task of this milestone was to create a test prioritization tool. This tool parses the test results of the 100 builds performed in the previous task. The tool then averages the time for execution for each test. Based on whether the fuzzing operations cause that particular test to succeed or fail, the test is categorized into either the success.json file or the failure.json file. These reports are also sorted by average execution time. The last task of this milestone was to create an automated test generation tool. The tool uses the Esprima AST parser to analyze the Node.js source code and add the appropriate routes to a testing file. These API routes are called using Node.js's request module, all the while the Istanbul middleware tool is recording the coverage of our application. We then make use of the HTML publisher plugin for Jenkins to make these results visible in the Jenkins dashboard. The third milestone topic is deployment. The first task of this milestone was to create a basic deployment strategy for production. We achieved this by updating our original Jenkins configuration Ansible playbooks. During the automated setup of Jenkins, we also now create a checkbox.io and iTrust production directory. We initialize Git repositories in these directories and set appropriate post-receive hooks for each application. These post-receive hooks then provision and configure remote virtual machines for our applications. The second task of this milestone was to implement an infrastructure upgrade, which involved creating a Kubernetes cluster and using that Kubernetes cluster to have feature flags enabled. First, we used the DigitalOcean API to provision 3 droplets. We then used a combination of Ansible playbooks and Docker files to set up Kubernetes and Redis on the 3 droplets. We used the same droplet as the master in both Kubernetes and Redis, following the master-slave model. This allowed us to mirror any changes to the Redis server between the 3 droplets, enabling feature flagging. Kubernetes also allowed us to maintain availability of the application, regardless of whether an instance went down. The third task in this milestone was to create a canary release strategy. For this, we updated our provisioning and configuration scripts so that both the canary and stable versions of our checkbox application pointed to a common MongoDB server. We also installed Redis on the MongoDB server so we could use it as a load balancing proxy. Using Redis and a tool we wrote in Node.js, we routed a portion of the incoming traffic to the Canary server. Another feature of the tool we wrote is that if the Canary server goes down, 100% of traffic is routed to the stable release. The final task of this milestone was to implement a rolling update strategy. Similarly to the previous task, we updated our provisioning and configuration scripts so that each instance of iTrust pointed to a common MySQL database server. We also wrote a simple monitoring tool and installed it on our Jenkins server, and this tool ensures that only one iTrust instance is updated at any given time. We then used Ansible's serial function to run an upgrade playbook on each of the iTrust instances one at a time. The fourth milestone topic was to implement anything we found interesting or useful, and since this material has not been included in a previous screencast, we'll be showing code execution instead of diagrams. The first feature we added to the pipeline was an automatic recovery tool. First, we'll bring the tool up, and as we can see, all of the 3 droplets are doing fine. Next, we'll destroy one of the droplets and demonstrate how the tool responds. Once the tool discovers that a droplet is unresponsive, it begins a countdown to a reprovisioning and reconfiguration of a node. And when that threshold is reached, it successfully reprovisions and reconfigures a new instance of the application. The second feature we added to our pipeline was integrating monitoring with the new Relic platform. This required us to update the configuration playbooks for the checkbox.io project. Once the provisioning scripts and configuration playbooks have run successfully, we can see that we have monitoring information for each of the 3 nodes. If you'd like to see screencasts of code execution for the previous milestones, please see the links included in the description. Thank you.